Welcome to the Mining and Metallurgical Society of America webinar series. MMSA is an association of mineral resource professionals whose members represent all facets of the mining and metallurgical interests, both domestic and internationally. If you are interested in becoming an MMSA member, be sure to check out our website at mmsa.net for information on the application process. MMSA has always been a cohesive group of senior people from the mineral industry. The society is dedicated to increasing public awareness and understanding about mining and why mined materials are essential to modern society and human well-being. The society concerns itself with fundamental principles and with problems facing the industry in such areas as legislation, economics, and education, as well as environmental concerns, labor relations, and health and safety. Representatives of the society from time to time testify before legislative bodies and provide advice to federal agencies. I am Kristen Guerin-Davy, MMSA member and the social media and webinar director. I'll be introducing today's webinar. The title of today's webinar is Future of AI, Spotlight on Domain Knowledge by Dr. Ganguli, Malcolm McKinnon Professor of Mining Engineering at the University of Utah. Questions can be entered in the chat. The speaker will answer the questions after the presentation is completed. Please turn off your cameras unless you are asking a question. I'll hand it over to Curtis now.
Thank you, Kristen, and thank you everyone for taking the time out of your day to join us. The Continuing Professional Development Committee of the MMSA is pleased to present Dr. Ganguli today. Dr. Rajive Ganguli, as Kristen mentioned, is a Malcolm McKinnon Professor of Mining Engineering at the University of Utah. Besides academia, he has worked as mine foreman and engineer in both India and the USA. He has been teaching and applying AI to mining industry problems for about 25 years. He is the author of the chapter Machine Learning, the Language of Safety in the new Mine Safety and Health Handbook from SME. The free AI software from his research group, Ute Analytics, has been downloaded in 28 countries since its release in 2023. Dr. Ganguli, please, we look forward to your address.
So before I start with the talk, I thought I'd start with the story because that captures the domain knowledge aspect of it. So I recently had surgery, and knowing my expertise, the doctor said, Rajiv, it's great you're in AI. Let me show you what AI has recently done for me. And so this was Apple Intelligence. He showed me his photos organized by Apple, and he's a surgeon. And so Apple provided him lunch options in Midvale, Utah. Midvale is where the hospital is. And these lunch options, the photos were all human body parts, right? So this is a surgeon that takes photos for his clients, and Apple Intelligence has conveniently classified them as lunch options. So as funny as that is, right? A lot of things went right on that AI, right? So the fact that it's lunch option in Midvale, well, it tagged the GPS correct. The fact that it looked at body parts, these are biological organs, it linked them to food. Body parts are body parts. So to some extent, animal body parts, human body. So it got that part right? So a lot of things were right in that AI, as funny as that was. What was missing was the domain knowledge, right? It did not know that this is a surgeon's phone, this is human body parts. And right there is really what this talk is about, right? So before I get going, right, so about my group, what do we do? My group, I named it AI.sys. We do both systems engineering and AI. And I've been doing AI since long before it was cool to do so. And so we do industrial scale AI. We work with mining companies and big projects. And mine to mill is an example of some projects we have done in a couple different countries, geology to mine to mill type stuff. And then a lot of chat GPT type stuff, generative AI and other things. And the differentiator between us and many others is perhaps that we do algorithm development. Everybody is an expert in AI nowadays, but most are learning how to use AI. And so they use AI in a novel situation. And so that is a AI user But what we do is, given my old school training in AI, we tinker with the mathematics behind the AI. So we are actually making the AI better. And I'll give you some examples of that. And so we are developing some AI for geological modeling, and our results are better than what you'll get out of scikit-learn or some commercial tools. I'll show you an example of the summarization tools we have done better than ChatGPT, right? So it's because it's that domain knowledge aspect. Um, so evolution and expectation. So it's interesting, when I first started in this line in the late 90s, I would go to a mine and mention AI. And, mining companies are nice to professors. They would listen to me. They would give me a t-shirt. They'd give me a lunch, coffee, and then chuckle and then ask me to go. And I got a t-shirt as well. And so that was it. But now, right now, it's well, you're the AI guy, and this magical tool. Tell us about this, and it's going to provide us very deep insight. Whatever deep is happens to be in the imagination, right? And so that's nice to be at the other end, but there are issues with that, right? And so you have heard some of these things already. Uh, Despite what a promoter of AI, a billionaire that makes money on AI, says, this person that writes some of the mathematics behind AI and my team, we really don't feel there's a lot of intelligence behind the AI so far, not in the way humans are, right? And then the other thing is, and many will agree to this, is that AI can only solve problems that humans can solve. So it's interesting to pause here, right, for a second, because in the hoopla surrounding AI, this gets lost. People just assume if we cannot solve it, just throw it to AI. Well, actually, if you don't have a good idea of how to solve it, AI will actually not be able to do it. So, what can AI do, right? So, here is you have a goal, and to model this goal or to achieve this goal, there are three key things or several key things. You actually don't know how many there are, but you inventoried information and you said, all of this information is super important if I want to understand the goal. Okay, but there is this one hidden factor you know nothing about, the one in the gold, right? So what will AI do for you? It's going to process that information. So this factor that was blue, it turned it into green and red. It did all these permutations and combinations. And in doing so, it told you that this factor, this third one, is actually not effective, and which you did not know before, right? So AI did that. That was great. Computers are super good at permutations and combinations, right? So what about that factor in yellow, right? This one, you didn't know about it, so AI didn't know about it. It is not about to tell you what you need, right? And so that is a big thing. So if you don't know about your problem, um, AI cannot do that, right? So what are the challenges? So one way you address this issue that you don't know, and you perhaps understand that AI is limited to the data it's given, so then you throw the kitchen sink at it, right? Our focus, so a typical thing is just give it everything, right? But giving it everything is actually not good AI ML at all. In fact, and I'll perhaps say this again, we use before AI, it was big data. That was fashion, and everybody thinks of mining as big data. Mining is actually micro data. It's laptop scale problem, and the scale problem, that laptop scale problem reduces to a trivial problem by the time you do good AI on it. The amount of data you reject, and then you do the AI on it's actually fairly trivial. And so that's not the case, right? So what's the issue? We have heard about data quality. We all know this intuitively. And when we talk about a mine, right, the mass balance is perhaps the most important measurement that we make, right? Everything. If you don't know, if you're miscounting the copper you're producing, then you will or the tonnage you have, you would make all kinds of errors in process and decision making, right? So here's an example from a large industrial customer we have. And so as many here in this seminar webinar, you already know there is the mine tons, and the mining folks, the mine engineers produce tons, they dig out of the ground, and then they send some tons to the mills. And they never agree. My first boss in India, he used to say, work extra hard today because those people in the mill, they're going to throw away our copper, right? So there is this rivalry built around this because nobody can agree on what was actually produced. And because there is no such thing as a mine ton or a mill ton, these are estimates based on estimates, right? And so mines know this. And so there is this massive reconciliation that most mines will go through periodically to adjust that, right? So at this mine, you can see this dance here, the difference between the mine tonnage and mill tonnage, right? And so you see up and down, that's great. But what happened there, right? And so when I got hired and my team started engaging with this, and so I knew enough to do this check. And so I had to first figure out what the heck mine ton means at this mine, right? And what does mill ton means, and where are these numbers that I look at? And so that in itself was a task, right? But if you don't know to do this, or if you don't go to the right sources of information, you are going to be impacted by this, right? Any mine to mill process in a situation like this, where you're spanning the mine and the mill and that connection, if you have this massive, this was, by the way, 20 million tons over a few years, you're going to have bad conclusions. AI is complicated enough to give you conclusions. You will always find something with AI, and that is the problem, right? And so many times when I joke about a surgeon's body parts being mistaken for a lunch meal, that's funny because we know the reality. We know that is not lunch material. But for abstract stuff, you actually don't know. If I told you your pH is affecting your something else, intuitively, yeah, it may or may not make sense. Right? It may make sense. And so you will accept that, even though that is the wrong conclusion, right? So what are the problem areas? Sensor data, right? And so when you look, trucks are rarely, or you may have 30 trucks. A big mine may have several trucks, and they're not calibrated. You don't know, and so people accept those numbers as golden. When you talk about mine tons, that's what it is. Many times it's from your dispatch system. And belt scales. People in the mill will tell you, belts rarely ever get calibrated. When I was a foreman in Alabama, my boss didn't give me a mechanic unless it was a MSHA requirement fix. He said, hey, we're just going to fix what's broken. And so, and that's how it is because you have shortage of people and all that. pH is another one. Uh, and so particle size, it's just to use particle size and then real-time grade measurements. What's interesting in all of this is some of these technologies work really well at a certain scale and they don't work well in other scales. But in our enthusiasm for more data, what happens is these technologies get deployed everywhere. So people forget the physics or they're too busy to look at the physics. A technology that penetrates 4 mm into the rock is used to measure the grade of a big rock. It's like, look, that's not the right thing. And then they might say, well, the vendor has guaranteed accuracy. So it's like, have you actually read the vendor material? They're guaranteeing accuracy at 20,000 tons. And if that is the case, why are you taking dispatch decisions at 300 ton scale? Because that number is not accurate. And people think that errors even each other out. They don't, right? The copper you throw away is not going to be made up by a wrong measurement of rich copper, right? So errors are always one way. So this problem is actually quite big. And there was a paper we came across in apparently the US oil industry loses $20 billion just because of bad sensor. And so, yeah. And then if you probably read about the Boeing Max, and the only reason that plane kept crashing is because of that single point of failure. That one sensor that was bad. That's it, just one sensor, it caused accident. So you can look that one up, right? So the other thing in all of this is we read a lot into the data. Data and information is not the same. A cliche, but this is how it plays out. Your belt camera says, the crushed rock particle size, by golly, this morning it's all high. But it really does not mean your rock got harder this morning. It just means the images of rock on your conveyor belt is high. And big rock, a rock that looks big on camera does not necessarily mean hard rock. And yet, when you go to mines and you look at the nitty gritty of how things are programmed, this is interpreted as hard rock, and then mill's operation changes as a result of that. So you can have sophisticated AI in there, but you know what? It's just making mistakes. And so the other thing that happens is materials. Hey, whenever we turn on number 4 belt is this hard rock stockpile, and the rock's going to be hard. It's not. And that we were doing this project for a large mine, and I was doing various checks, and there's things that didn't make sense. And so I called up at that time my current student, or my postdoc. He was at the mine, and he checked, and he found out that on certain days of the week, a certain belt reported to the belt's destination was something else, which is why, because I was making all these fundamental checks, I was able to catch him, right? So it's all these things, they get lost if this AI is done by somebody that is not familiar either with mining or with the nuances of the process, right? So Curtis and I talked about this talk before when I first agreed to do this, and he said, let's talk about mining and how can small mines benefit from it, and with that context. Uh, so one way to have that discussion is perhaps to break AI problems down, right? To see what kind of problems AI handles. So this is my own thing. I use it in my talks to explain capabilities of AI. So when I look at this world, I divide the problems into two. One are bounded problems. What are bounded problems? This is like you walking into your bedroom with the lights turned off. You know where the furniture is, you know what's in there. You can't see it, but you kind of know what's there. So in these types of problems, you kind of know the key factors. The physics is well known. You have lots and lots of data, relevant data, and data quality is okay. It's not bad. So you have very good handle on this problem. And examples of this: a mill processing plant, in most parts of the mill are going to be a bounded problem. And face recognition is definitely a bounded problem now with all the advances, right? And so the face is within those pixels, right? And within that color schema and all that stuff. So AI is great for these. It's really very simple AI problems. And so when you read papers and when you see examples, this is really great. This type of problem is great for minds of all scale. All you have to do is turn on the light, right? Light switch, that's it. Very simple to do. You're set up for AI, classic machine learning approaches, deep learning. And you see like videos, making conclusions from videos, or observing if your belt is this way or that way. All of those types of things are all bounded problems, right? Great examples of AI. But this is really where, when we think of AI, we think of this, right? That this is a nebulous problem. It's like this thing, can you figure out a way out of this maze? Sure. Is it obvious? No, it's not. You have to stumble and your way through this. This is a hard one, right? The problem is not defined or undefined, and so you kind of know something is not working, but you don't know what is not working, right? Physics, I will keep talking about physics. In Peru, they asked me, what should we look for when we hire engineers? I said, make sure the engineers you hire have good background on physics and chemistry, because otherwise they're going to be not questioning the technology they buy. Look at the fundamentals. So really, the data will not make sense if the physics does not make sense to you, and if you're the natural intelligence. And so that's there, right? So if you don't know the physics, you don't know how anything works, then it's hard to do it, right? So in these types of issues where the data quality is questionable and all of that stuff, right, it's hard to do. The mine to mill projects that we have done for mines, they are like that. People roughly sort of think that the rock affects the mill performance. It's hard to connect the two because of a variety of reasons, right? And so we have been able to actually connect them really well and back map mill performance to mine site locations, but it was navigating this thing, right? So it took time to do that. So why are these unbounded problems challenges? So during COVID times, the National Academy of Sciences, they had a shindig. It was, of course, on the web. And they asked the technology managers of Google and Microsoft, and they were panelists, and they were asked, they said, US is a leader in AI, and yet we don't see AI applied everywhere. So this was before OpenAI's ChatGPT was released to the public. And so they said, we have domain experts up the wazoo. We have experts in everything. And we also have experts in AI. But what we don't have are these people in the middle. And this is from the technology experts, right? And so where we have found success, my team is in mining. You can't be my graduate student unless you worked in the mines. So if you have 3 degrees in a row, sorry, I want you to go work at a mine before you join us, right? So every one of my teams, they have mining background, I have mining background, and of course we train them on the mathematics of it. So we know both sides of it, and we find that's where our success is. So what does that look like, right? And so this is an, again, industrial example, just a simple classic bounded problem approach. It was a mill, and it typically, if you go to any number of presentations, you will see they take data there for X number of years, they randomly develop, split that into 70-30, they apply some sort of machine learning, and then poof, they say we have understood the model. That's typical. Nothing often wrong with that. When it is a process control, so that's like say geology type example. In a process control, they might make it more adaptive. So the first 70% goes into modeling, and you predict, and that's how that's done. So that's your traditional approach, right? The problem with that is when you start deploying that model, for a very short time, the model's going to do well, and very quickly it starts diverting, even though your mill or your process has not really changed. And there are reasons for that, right? So it's really not an effective approach, even though that is the one that you see on papers. And speaking of papers, we also publish papers because I'm an academic, and I have to be in the game. But we don't really publish our good work. So it's always our second best work, because the best work is you only get that when you give me an account number, right? So that's the reality. So what did we do, right, in this process? So we have the same data set, and it took me a while. It took me several months to tinker around, and I figured out what to do with it. And so we developed a machine learning model based on the 4%, first 4%, and then we tested it on the 96%, right? And so then how did we do? We actually did phenomenal. And we did better than scikit-learn and some of the commercial tools we benchmark ourselves with, even when we give them the same advantages of knowledge, right? So this is where this comes in. So for us academics, so people that do this for a living, there are opportunities in modifying. So these are some of our partners. I can name some. I may not be able to name everyone, but here there are. And so you can see the scikit-learn is the commercial algorithm done the right way, and so on and so forth. And then you can see my algorithms here where we screwed with the math. And so in predictive processes and other stuff, being able to predict better is actually, there's money in it, right? So we know that. And you can kind of see in here the SAG mill, the performances are pretty good across the board, because some of these things are now very easy to deal with machine learning. And so you get very good performance, but you can see some of the differences, certainly in ore body modeling and others, where by screwing around with the math, using your domain knowledge and changing the mathematics, you get some benefits. Here's one, enough with the numbers. This is the NLP side of our business. So Chat GPT enhanced with domain expertise. So this is a summarizer. You have probably all seen the ads, the Apple ad. The girl goes to this high value meeting and she has not skimmed the email that was sent to her by the person she's meeting. And so while talking to the woman, she quickly reads the Apple intelligence-based summary. So this is now the fashion du jour. All these companies are giving massive contracts to OpenAI and saying, hey, use our reports and summarize, right? So we know that's where the industry is headed. And so this is what we did, and I'll show you what ChatGPT would do. So we are using ChatGPT, but we have other things we are doing quite a bit differently. So here is the summary, and we chose to break it down into 3 parts for safety narratives because I feel both as a foreman and as somebody that worked in the mines, these are the types of things I wanted from incident reports, right? So this is from reading narratives. So the nature of the accidents could not be determined, but they involved so on and so forth. The accidents happened in some underground and some locations, right? And the nature of the incident, the injuries, what kind of injuries there were, how many body parts, and how did that happen, and then what was the effect of the injury, days away from work or whatever. Okay, sounds good. So this is informative to the mining engineer, right? So now what would Chat GPT have done, right? So of course that was the end product. So when you look underneath the hood for us, we are looking at this and evaluating the technologies. So on the left column here are the numbers for Chat GPT, and then here is our technology, right? So accident classification by default, ChatGPT was not very good at that. It's about 30% accuracy versus 90% for us. How about mining equipment? So 34 versus 78. So you can see, in this case, unlike the random forest, everything is actually my code. Here we are actually interfacing with ChatGPT. So it's a ladder on top of ChatGPT. And so, because, large language models are big things to build in-house, and there's no need to do that. So here we are, right? So you see the accuracy. So the same summary here done by ChatGPT would have wrong details in it. So now imagine you had ChatGPT summarize 1,000 reports and it tells you, your belt conveyor people are not doing a great job, and you go and chew them out, right? Was that actually true, or did you actually read the 1,000 reports? Actually, if you read the 1,000 reports, you would not know, you would not have the wrong conclusion, right? But the point is, when we start using these technologies, these summaries, they look very reasonable. If instead of the sources of injury consists of 4 instances of rock, coal, ore waste, and 3 instances of hand tools, let us say there were no hand tools related injuries, right? And so then what? But how would you know if you were summarizing all those, right? So these things, they make a difference, right? So it's hard to tell when the AI conclusions are reasonable. All right. So speaking of that, so I'm very big on AI being done by domain experts. And so we have been giving out this tool. This is for bounded problems, and this is not for NLP. And so I'm trying to figure out if we should build our NLP tools into this, but this has been downloaded from 28 countries. And it's interesting, most of the active users are outside the US, the mining engineers from the Chinese mining companies, interestingly, and some in Australia and so on and so forth. And some of the Indian schools are using this in their training. So yeah, a lot of users, it's free. We have nursing people use it at the University of Utah, and so on and so forth. So download your copy if you have bounded problems, and it comes with a manual and so on and so forth, right? So do your own AI, right? So recommendations, chase bounded problems. Do these first. You don't have to do this pixie thing. There is no need to chase this nebulous stuff. Of course, if you do decide to chase, you can think of yours truly, and our research group would be happy to assist, right? But chase this, and a lot of the I had a short course in Peru, and all these guys, they went back and they're doing all of these, right? They're doing this, I call it micro AI, because when you look at it, a mining data set, right? A dispatch system, there's tens of thousands of rows of data. Maybe, one of the larger ones I did was like 1 million rows of data. 1 million rows of data and 100 columns is fairly trivial, right? It's really, from a computational perspective, this is very, very easy for a laptop to handle. And then, by the time you reject, you conduct all the checks and you do it. By the time you do this, now you're really in a silly little land where you can do this exercise as a class demo in a classroom, which is what I do, right? So these are all micro AI. And I always chuckle when I see these ads for cloud and giant. You actually don't need any of that. You can give your engineers a laptop, and most do, and you can do your AI on the laptop. And the laptop's like, it's phenomenal, right? You have, let's say a simple machine has 16 gigs of RAM. You can do tons and tons of AI on it. Do not start with a large AI initiative would be my recommendation, unless your goals are well defined. I want to be better at producing copper is not a goal. It's not a well-defined goal. On the other hand, you say, I want to reduce power consumption in this particular machine or process. Very, very narrow. That's a well-defined goal, right? So it has to be very tangible. I will use ChatGPT to get better. Get better at what? It has to be very, very specific. And then the second part to the question is, how is your data around that problem? Is it okay? So you want to reduce power? Great, narrow goal. What about the power, the data that goes into it? Do you have confidence about that? And so I always joke when I start with the industrial client that the first outcome of our AI work will be depression. When we tell you all the ways your data is wrong, right? As we do that, it's not a stopping point. You just have to do AI differently. You cannot do it the way McKinsey would do AI, right? Put 20 people on the ground and poof, 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 $20 million are gone. And then they're all coming. There's fantastic PDFs with great graphics, right? So that's going to be hard, right? So start small and let it grow organically. And it's really build in the lot of time for engineers to think and question, and let them be the designers of the AI, right? Let them do it. Let them figure, they know the process. It's really, really, really all about the data. AI will handle any data you give it, and that's the problem, right? So make sure the data that goes in, you have thrown away most of it, and you've taken the right amounts, and you figure out why that's the right amount. I tell my students, act like a lawyer. You ask every column of data why it should go into your AI, right? And if the column cannot answer it very well, then it doesn't go in, right? And finally, honestly, I don't know why we have forgotten systems engineering as a profession, right? This was the thing back in the days, but now we have more data. We can actually do a great job systems engineering. Most minds will save money through systems engineering, but they'd rather go buy the 10 extra trucks and have a large AI initiative. AI is very sexy, but this is actually cheaper, and most will get more benefits out of this immediately, right? Sorry, this was not AI part, but so here is the thing, right? As the romance matures, I'm starting to see companies evaluate AI more honestly. And some have laid off their big divisions, right? So these technology divisions, the mining companies are laid off because they realize it's not really working. It has to be a lot more thoughtful. It has to be slow process. And the domain experts, I think, nobody wants to go against AI or speak up because you don't know the field, and so it's wise to be quiet when you don't have enough knowledge, and that's how it has been so far. But I think as people are learning more and more about AI, right, that the domain experts need to speak up. If it seems silly to you that somebody's solving like those large language models for time series, right? It's funny, but you know what? Billions of dollars are being spent on those. So if you're a domain expert and if it sounds funny to you, speak up, because the only real intelligence is actually you. It's not all that software code, right? So yeah, so I'm ready for questions.
Great. Thank you so much. Are there any questions?
This is Curtis up here in Toronto. We've heard a lot about AI applications in the exploration side, primarily to deal with the vast volumes of geologic data and help narrow down the focus towards developing targets for ground-based exploration and the most expensive exploration being drilling itself. Have any of those issues come to your attention, and how have you addressed those when they came?
So there's a company talking to us about it, but we're still talking. So in that space, I see two types of things. Both are sort of like the bounded problem type issue. One is where they use AI, say, to do automatic core logging. It's basically an image recognition problem, and so it's I think depending on how much legwork some of these companies have done. By this, I mean the technology developers. I'm not familiar with the image processing side of things. I don't know how mature that technology is. So that is one side. And the other side is more along the line of what we do is once you have your grades in a 3D space, um, we are able to use like the algorithms I mentioned. We are on the cusp of explainable AI. So I'm still testing it, but we are able to explain why in certain parts we are doing better versus another. And so one of the criticisms of AI always has been that you don't know what the heck you're doing or why it's working. And so we think we should be able to tell that soon, certainly for geological deposits, right? And yeah, and so yeah, so that's what it is. So Kurt is in the exploration phase, the image recognition part of things, where you're doing automated core logging based on imagery. There is that. I don't know much about it, but if done well, I don't see why it wouldn't work, because it's a small enough problem. It's not too nebulous. On the other hand, the your classic, I have a drill hole database and I have, say, 500,000 intercepts. What can I do with it? Yeah, we can help you with that. That's very doable. Yeah, yeah.
Great.
Uh,
I have a question in the chat here from Andrea. Where do you see
yeah.
AI or machine learning being most effective too in the minerals industry? Should we be focusing research efforts?
That's a great question, right? So Andrea, you're unfortunate mining academic like I am, right? And so what are the challenges we have? There's tons and tons of funding in AI, just nobody cares about the problems we are searching. So what's interesting is all of my work is funded in very odd ways, some through mining companies, some through others. So if I were to be a wise person and give you advice for research, I don't know if there is a lot of money in this yet, right? But if you want to make a difference, then really you start with the bound problems. The algorithms have a lot of room for improvement. So when you think about AI algorithms, right, it comes from computer science. Computer science comes from internet scale problems. So the way you search a space, a vector space, it's different when you are looking at internet scale versus a million rows, right? Two different things. So the mathematics can be very different in both cases. So when you automatically say, well, I'm using Google's toolbox was done for internet scale data. So the mathematics there is for that. Is there something you know about your deposit, about your problem, where you can change the mathematics of how a neural network is working or how a random forest or something else is working, right? Have you yeah, actually, our reserve estimation is very old school. Yeah, we actually do this. In fact, I showed some results here, and we are doing that now, and we are doing fantastic. We are beating the commercial, the scikit-learn tool. Yeah. So this is Betty's question there. Yeah. Yeah.
Thank you. Appreciate it.
Yeah. Yeah, or reserve estimation is kind of set up, right? I mean, this was the playground of us academics 30 years ago when we started in this, because you have nice columns of data, you can play with the mathematics, and there's like a billion papers on them, right? So what do you think of language summarization? I think in generic language, it's fantastic. So if I were to summarize soup recipes, I would use ChatGPT and not think about it. Then when you bring it to text, it has not seen very much of. Perhaps like I was developing algorithms. And so the text kept mentioning pinners. So I was a summer intern in the Appalachian coal mines. I know what a pinner is, but you know what? AI would not know that. In fact, it did not know what a pinner was. And so the thing is, as we all, and what's interesting is, my team has been working, because you use these algorithms all the time, and we started noticing difference in how ChatGPT was responding after like 2 years of our effort. And so we feel like some of the things we were doing was perhaps affecting. So perhaps as more and more people use language summarization on mining corpora, the mining text, perhaps it'll definitely get better, right? Yeah. But as of now, I'm not so sure, because with the safety narratives and all that, it's not. It's really good in some aspects, and uh, can you add, and some it's not. Yeah, and so this is where that's exactly it, right? And so we have added our own jargon to this, and this is why we are very effective, right? So when you saw uh, the performance difference between ChatGPT and um, and ours, it's because we know how to interpret the jargon, how to massage it, and a lot of these things. Yes. Yeah. But like I said, it's not something that you just say off the can, I gave a contract to OpenAI. You better be ready to give it, the right examples. Your domain experts have to be involved in it. Yeah. What AI accomplishment has most impressed you? I would honestly say the large language models, right? I mean, when you read the paper, it's so dry. It's interesting. A lot of people don't know Google is actually a pioneer, and then they gave up on this because they were worried that the technology would be abused. So they slowed down their investment in the large language models. One of the papers you cite the most is actually the one from Google. And so then OpenAI, which was supposed to be this nonprofit type thing, they jumped the gun, right? They turned into this for-profit machine. So it was funny, a technology that Google pioneered, Google was behind on and is still not considered a leader on it. So yeah. But yeah, I would say the large language models have been very, very impressive for me personally. So yeah. But the large language models on time series, I'm sorry, I'm not seeing how that would work.
We have a message here from Lewis. What AI accomplishments has most impressed you?
Yeah, and so the large language model, the chat GPT type stuff has generally impressed me as a general user. I ask my graduate students to write papers. Like, I have found that the time to review a thesis was dramatically short after I required that they write the thesis, put into chat GPT, have it rewrite it, and the languages come out much better, right? So it's actually saved me time, and it's fantastic. So with this being a new, how can you convince companies to change their current practice? So here is the thing. So I will be critical, and so you can send the nasty grams to Kristen, who will not forward this to me. But I'm going to say this: I find that the culture between American companies and others, particularly Chinese and South American companies, and to some extent, there's a big cultural difference. In the other countries, they trust and rely on their engineers a lot. In American culture, there is a culture of subcontracting it to the largest shiny contractor you find. So they chase the big names, right? And so what I find is, so I look at the Peruvians, I look at the Chinese mining companies. It is amazing. Their domain experts are doing the AI. And I tell you, they are doing better because they know their process, right? AI is not about the math, it's about the data. And so they will always be more successful. And so hopefully, it's hard convincing, right? Mining companies uh, to to go small, not big. They want to go big, right? Because the trucks are getting bigger every year. And so they want to do the same. Let me hire 80 people and have this AI division. Can't. I would not do that, right? So, yeah. So send them to short courses, send them to learn AI, right? So, yeah.
So let me ask or say something here. I've been doing, we've been writing a whole lot of papers on a subject matter that we really want to engage the public with, and they're not really being engaged. So I use ChatGPT and threw the papers in, the technical papers in, one by one, and asked ChatGPT to write a dialogue back and forth between two people talking about what's in the paper and identifying the issues that come forward, and to do it in a conversational tone. And it did a beautiful job. I don't think we're thinking outside our own box about communication. And if we ask the right questions of ChatGPT and tell it how to do it, it will do it. And we can use it to our benefit.
Yeah, I agreed. I mean, the LLMs, that has been the most impressive for me, is the LLM. It's fantastic. Yeah. Yeah. Yeah, AI is already assisting this. Yeah, absolutely. Absolutely. So this is Art's question. This is actually in many ways, it's a bounded problem, and AI will do and can do. And so there's a lot of tools coming out for doing automated stuff. I do a lot of, there was this big industrial client, and as I did this art, this is exactly what I was doing, very close to that. And I did a lot of traditional AI type work, and I gave them a presentation. After the presentation, I told them that 70% of my slides were actually wrong. They were all data driven and correct. They were all done using the traditional wisdom of AI. And I said, look, this is where you're going to get trapped. And so, of course, I gave them the right observations later on, and we achieved fantastic results. But Art, this is exactly, yeah, you can absolutely do that with AI. It's very doable now. If you trust your data, it's actually very simple to understand some of these things now. I would say download Ute Analytics, play with it, right? And do that first pass. And after that, if you have questions, you can always call us.
So with that, many thanks to Dr. Ganguli for his excellent presentation. Thank you so much for attending this webinar as well. Our February webinar is confirmed for February 21st, 2025 on minerals markets. You will get a notice of our upcoming webinar as details are finalized. The webinars are generally scheduled for the third Friday of each month. All of our webinars are uploaded to YouTube and can be accessed through the mmsa.net website. The video of this webinar will be on the website within a week. The MMSA webinars are supported by the MMSA Jacqueline Foundation. We will send you a note when the video and slides are posted on MMSA website. And again, if you are interested in becoming an MMSA member, please be sure to check out our website for information on the application process. The webinar is now ended. Thank you.